Okay, hello. Let's see. Well, we're back. Hope everybody had a good break, Christmas break. Happy New Year's. Everybody was safe. Had a good Christmas and New Year's. I can't complain. Let me see. Let me get this mirroring back on here. Sorry, kind of went off. Just give me a second. All right. Okay. So here's homework 17. Okay, we're back from the break. Um, Let me just kind of fix this a little bit. There we go. All right. Like I said, hope everybody had a good break, good Christmas break. They're ready, they're relaxed, they're good to go. Um, the picture that's on the first part of the homework, the little thumbnail that's on here, not this, but the little two rectangles, and it said K equals 4, I believe it was. That's what we did today was effects of scale factors. So there's a couple questions on here that have to do with the effects of scale factor. So what I'm going to do is when those questions come up, I'll let you know, kind of give a brief overview of the lesson in case there's any parents out there that want to know what it is that we covered today, maybe how to help their son or daughter answer some of the questions, maybe give them a little hint and stuff like that. So that's what we'll do. We just have homework today. We'll have homework tomorrow. And then it's already Friday, so kind of a short week, so that's good. All right, let me get my pen, and then we can get started here soon. Where did my pen go? Can't find it. Where is it? Is it in my pocket? I bet it's in my pocket. No, it's not in my pocket. Back here, yeah. All right. Okay, now we're ready. Okay, so number 1 says using the table below, write an equation in slope-intercept form for the relationship between hours and the money earned. Okay, so I'm going to go ahead and blue. Whoops. I'm going to circle slope-intercept form. Okay, remember slope-intercept form is y equals the slope times x plus the y-intercept. Okay, y equals mx plus b. So slope times the variable, which is x, plus the y-intercept. That's what the b stands for. So however many hours multiplied by the slope multiplied by the hours plus whatever the y-intercept is going to give us how much money is earned. Okay, so what we need to do, get my blue, black, right there. Zoom in on this table, right? Because we're going to focus on this table here. We need to find our slope first of all. Okay, so we need to find the m or the slope. So we're going to find the change in y, which is the money column of this table, right? The change in y, and we're going to put that over the change in x, which is the hours of this table. All right, so remember, we're just kind of subtracting from the bottom to the top. So $20.25 minus $19.75. That's going to give us a difference there. Okay, that's a difference of 50 cents. All right, I'll kind of help you out on that. We'll kind of just start putting it in. So that's 50 cents. From $19.75 to $19.25. That's also 50 cents. And you can kind of see the pattern that we got going on here. This is also going to be 50 cents. All right. Make these dots a little bit bigger because I don't like the way they look. There we go. Okay. So since I have that there, that's going to be what's the numerator of my slope. So I'm going to put 50 cents, 0.50. That's going to go on top. Now let's find out what my denominator is going to be of this slope. So we'll go over here to the hours, and 8, 6, 4, 2. I mean, obviously we see that this is going up by 2. So now you see that they're all the same. So I'm going to put that down here. Okay, so 50 cents over 2. We can put that in our calculator, and let's find out what that's going to be simplified down to. 5 over 2. That is 25 cents. All right, obviously. So our slope is 25 cents. Okay, so this part right here is what's going to go right there in front of the x. All right, so I kind of helped you out pretty much with the slope part. Now, what you're going to have to do is find the y-intercept, and I'll show you how to do that here in a second. But let me go ahead and fill this in for you. Y equals 0.25x. All right, and now the y-intercept part of this is what we'll go to next. So let me get this. I just kind of scissors and made a table there. Okay, and then we'll go back to right here. Okay, so this is the table. I just kind of cut off part of it. The reason I cut off part of it is because we need to find where x is 0. So this is my x column here. This is my y column there. Just kind of make this table kind of like that. I need where x is 0, so we're going backwards. Look, 8, 6, 4, 2, and then the next number obviously would be 0. So we're good. We just need to find out what y is going to be when x is 0, and that's going to be my y-intercept. So that's what you kind of need to figure out. I'm going to leave that to you. Remember, this is going down. If we're going up like this, we're going backwards 50 cents. Okay, 50 cents, 50 cents, 50 cents. So just go backwards another 50 cents. You'll get your y-intercept, which is right here. Whatever you get there is what's going to be extended onto here. I'll just tell you it's going to be a plus something. All right, plus something there. Let me go ahead and box this in because this is going to be your answer, like so. All right, let me zoom out some so that you can kind of make sure it's all in there if you need to look. All right, I'll zoom in on this part first. You need to pause it right there. Okay, then I'll zoom in on this for the y-intercept part if you want to pause it there. All right, that was number 1. Okay, let's go to number 2. Triangle ABC has the coordinates A, which is -3, -3, B, which is 6, 0, and C, which is 6, -9. If this triangle is dilated by a scale factor of 4/3, what are the new points of triangle ABC? So we talked about aspects of scale factor today, but this is kind of what we did before what we talked about today, so like before the break. So what the good thing to do is we're going to go ahead and rewrite our points. Okay, so I got A, -3, -3. I got B, which is 6, 0. And then I have C, which is 6, -9. All right. So remember, I got these points here. My scale factor, which is what I'm going to circle in blue for you, is 4/3. So we're multiplying every single number here by 4/3. So I'm going to multiply 4/3 times -3. 4/3 times -3. And that's going to give me my new point of A, which is because that's what we're looking for, A prime, right? Remember, this symbol here stands for prime. These little symbols here on your homework. So A prime is what we're looking for. So we need to multiply 4/3 times -3. Once I do that, I mean, it's going to be the same thing for here too. So once I have that, that's going to give me my x. That's also going to give me my y. But then on the rest of these numbers is what I need to multiply 4/3 times 6, 0, and so on and so on. So we're going to get A prime. We're going to get B prime. parentheses, and then C prime. That's going to be our answer. Oops. There we go. For number 2. All right. Let's multiply by the scale factor. All right. So that was number 2. Here we go on number 3. A rectangle has the area of 63.4 centimeters squared. If this rectangle is dilated by a scale factor of 2, what is the area of the new rectangle created by this dilation? So this affects the scale factor. This is what we talked about today. Okay. So my scale factor is 2. So what we're saying is that we have a rectangle, and what I'm going to do is I'm going to, over here off this side, I'm going to make a rectangle shape over here. There. And this got an area of 63.4. I'm just going to put that inside here. All right. So with this rectangle of 63.4, I have a scale factor of 2. So K equals 2. Remember, K stands for scale factor. So if I have a scale factor of 2, if you remember from what we talked about, if the scale factor is greater than 1, then that means this is going to get bigger. So obviously my area of my new triangle or rectangle is going to be way bigger than this. All right. So what I would have is, what I would have is another rectangle that is like way bigger. Okay. So I need to find out what this area of this rectangle is going to be. So what we talked about today for effects of scale factor is that if my scale factor is 2, whenever we're looking for the area, which is what we're doing here, we have to square this scale factor. So it's going to be scale factor squared. So you need to square that scale factor of 2. From here, I mean, obviously 2 squared is 4. Okay, so now from here, you can multiply your smaller rectangle, 60.4. You multiply that times the scale factor that is squared, which is that right there. That's going to give you your answer for this bigger rectangle. All right, so that's what we got going on there. Okay, I'll let you kind of have some time to look at that. All right, that was number 3. Let's go to number 4. Okay, it says the coordinate A, -6, -9, is dilated by a scale factor of 1/3. What are the new coordinates for A? This is just like, which one did we do? Number 2, okay? But the only difference is it only has one coordinate, which is -6, -9. So A, -6, -9. My scale factor is 1/3. I got that from there. So you have to multiply these points. This x coordinate of -6 times 1/3. This y coordinate of -9 times 1/3. And that's going to give you your A prime point. Like so. All right. Good. So we're just moving along. All right. Number 5. Container A has 200 liters of water and is being filled at a rate of 6 liters per minute. Container B has 500 liters of water and is being drained at 6 liters per minute. How many minutes M will it take for the 2 containers to have the same amount of water? So we have to set up an equation because it's going to be the same. So it's an equation. So I'm going to have variable and constant for container A. I get this from my information in here. And then container B, the same thing. A variable and a constant. Now remember, be careful because container A says that it's being filled at a rate. So the being filled at a rate is going to be plus. Container B says that it's being drained at a rate. So that's going to be a minus or a negative. So however you have it. You're going to set this up, make it equal to each other, and then you got to solve. Okay, you got to solve for it and find out. Okay, you can use n as your variable. You can use x as your variable. It's fine, doesn't matter. All right. So that's number 5. You know, that's what we're doing on that one. Okay. Number 6. A circle has a diameter of 4.8 centimeters. What is the area of this circle? So we're looking for area of the circle. Now, don't get confused with the effects of scale factor, which is what we just talked about earlier. Don't get confused with that. This isn't that. All we're doing is looking for area of a circle. Okay? So, we're going to, if you don't know how to find the area of a circle, or you've got to find the formula of the area of a circle, if you don't know how to, look on the formula chart, look it up, however you want. I'll show you on here. We have, where are we at? Volume, area of a circle, right there. A equals pi r squared. There we go. All right. So that's the formula we're using. So A equals pi times the radius squared. Now, times the radius squared, so I need to know the radius because I know what pi is, okay? So if you have a circle, just kind of make a circle for you. Square, circle, there we go. So if we have the circle, oh no, I don't want there. Hold on. There we go. I have my circle here. It says a diameter of 4.8. So 4.8, I'm going to do this in blue for you. 4.8 is my diameter, which means it goes all the way across. So if you put 4.8 here where the radius is, it's going to be wrong because we're looking for the radius, not diameter. We use radius in this formula. We don't use diameter. So you're going to have to cut this in half or divide it by 2 to find out what the radius is. Once you do that, plug it in your formula right here, and you'll get your answer. Let's see. Red. You'll get your answer there. All right? Okay, that was number 6. Okay, number 7. Says, using the picture below, write an algebraic representation of the dilation. So, first thing we need to do, this is where we had our pink and green markers, right? So, we need to find out what's going to be new, what's going to be old, what's our pre-image, what's our new image. So, if I look and zoom in a little bit, I have this small triangle here and it has these marks there. I have this big triangle here that doesn't have the marks. So y'all are very good at knowing that the ones with the marks is the new image. So I'm going to highlight this smaller triangle right here in green. Highlight here in green. There we go. Just like what we've been doing. And then this bigger one is in pink or red on my thing. But so we're going from this big one and it's going down to this small one. Okay, so automatically you know that that's a reduction because it's getting smaller, and my scale factor is going to be less than 1. Okay, so it's been a kind of a while since we did this, so I'm going to kind of help you a little bit more on this one right here. How can I find out what my scale factor is? Well, I can do my new over old, right? I can do that. So I'm looking here at these triangles, and the only point that I can really point out is this A. This point A and this point A prime right here. Because look at B and C, like it's not on a line exactly. Okay? So if it's not on a line exactly, those are going to be harder to figure out. Because I don't know what this is. Between 0 and 2, I mean, it could be 1, but I'm not sure. I don't know what this is. It could be 3, but I'm not sure. But I do know that this A right here And this A right here, I can tell what those points are. So A here, I'm going like 0, 2, 4, this is 6. So A, 6, comma, and it goes up 2, 4, 6. Oh, okay, so 6, comma 6. Now let's find out what my A prime is. 0, 2, so 2, comma 2. So you got to find your scale factor of 6, going from 6 to 2. Remember, it's a reduction, right? It's getting smaller. So if you can't see that, then yes, do new over old. Put one of those points, they're on top, here, one on the bottom, there, reduce it and see what you get. Once you do that, then you're going to have x, comma y, because it's got to be an algebraic representation, comma, and then you're going to have something x, something y. So like, what you're going to have, it's another, in there. You're going to have something here and something there, which is what we're doing. Algebraic representation. Okay? All right. So that's number 7. Here we go, number 8. Order the following numbers in ascending order. 0.75 squared, pi over 4, negative square root of 4 over 2, and then 189,340,000 to the 0 power. Okay, so ascending order. I'm gonna again, if you don't have a calculator that can do most of these things, convert them, right? Because we gotta convert them to some decimals. If you don't have a calculator that can do all that, then set it up and then come in the morning tomorrow. Use one of our calculators here in the classroom. Ascending order means we're going up. Okay, it's going up. So if it's going up, that means it's going from least to greatest. I'll leave y'all at that. There. So least to greatest. Remember, you have to write it back in its original form. All right, write it back in the original form. Okay. All right. That's number 8. Number 9. What is the slope of a line that passes through the coordinates A, 7, 0, and B, negative 1, 4? So we have A, 7, 0, and then B, which is negative 1, 4. All right, this is our y's over the x's. So you can have like 4 minus 0, and then negative 1 minus 7, or if you want to put 0 minus 4, the y coordinates here have to be on top though, and then our x coordinates are on the bottom. So however you want to do that, that's what's going to go there, and then you're going to get, you'll simplify it, you'll get an answer. So kind of let me put some boxes where it is that you're going to have some numbers out. You have a number there. We'll have a number here. Oh, those are like off, but okay. We'll have a number here. Number there. Oh, not that. There we go. There. And then you just simplify that. You're going to get your answer of the slope. All right? So that's that one. Okay, number 10, last one. What is the y-intercept of the graph? So in blue, circling y-intercept for you. Okay, remember, don't get mixed up with this is about slope. Okay, I mean, yes, we do a lot where we find the slope and y-intercept, but you have to read the question carefully. It's not saying what is the slope-intercept form. All it's asking for is the y-intercept. So that's where we go here. I mean, literally, you just put your finger up top here, where the y-axis starts on this graph. You go down until that line crosses. All right, we're going straight down here until that line crosses. Find out what number that is. That's going to be your y-intercept. Equals That's a B because that's what y-intercept. That's the abbreviation for y-intercept. And then you're done. That's it for that one. All right. Okay, so that's it. That was the homework. Number 17. Hopefully you got a good understanding of it. The effects of scale factors is what we did today. So, yeah, that's all we got. Trying to think what else we can tell you. If you need to come in the morning tomorrow. I'll be here. Mr. Farron will be here. Come in, get a calculator. If there are some things that you can't do at home because you don't have one of the graphing calculators here, or maybe your calculator on your phone or something can't do that for you, then go ahead and come in the morning. We'll be here. All right? Okay? Thank you.